Hello everybody, this is the lesson number 3 and it's about binary system. The lesson number 3 from the course number 1, foundation level 1. But before we know or we understand or we go to binary system, we should to ask ourselves one question: how to represent data in computer. Okay, how to represent data in computer. And before we understand how to represent data in computer, we should understand how computer works. And from the last video, the previous video, we explained that the computer is an electric device and it deals only with electricity on and off. And we say that the CPU is contains from billions of transistors, and transistor is binary switch and prevents or allowed electricity. So the computer it just deal with on and off, and it just deal with electricity, and it's an electric device. It's only understands zeros and one. You should keep this in your mind, please, and don't forget it. Everything you see it, you heard it, you read it now on the screen, it's billions of on and off or 0011110. Everything now, you see me now, you heard me now, everything that you see it now, computer take it, represent it to 01 on or off. Change it. It means like change it to 01 on off binary system. So computer use binary system to represent numbers, letter, commands, images, and sounds. But before also we go to explain what is binary system, we should to see the difference or to know what is decimal system. Decimal system, it's base 10. It's our system that we use it every day in our life. For example, your phone numbers, your bank account money, you create from it hundreds, thousands, millions, billions. If there is any millionaire or billionaire, listen to us now. Please help us to build this channel better. I'm kidding. Just get back to our binary system. But binary system is just base 2. Binary system, they call it base 2 because it just has 0, 1. It doesn't have 1, 2, 3, 4, just 0 and 1. For that, they call it base 2. Before we go also to explain what is binary system, we should understand something. We should understand what is bit. And remember, computer is an electric device. It deals with electricity only. I put it like this because I don't want you to forget that the computer is an electric device, because a lot of things rely on it. So what is the bit? The bit, it's a box. Imagine that it's small, tiny box you have, just small, tiny box. That's a bit. It hold or stored one thing, 0 or 1. It hold one data or one thing, 0 and 1. It's so small, it cannot store a lot of things. So a bit is binary digit, that the smallest increment of data on computer. It just, as you see, on, 1, 0, off. So if I want, as I said, the bit, it's not like hold a lot of stores. But if I put 8 bits together, it will give me 1 byte. And the first bit, we called it lowest significant bit. And the last bit in the byte, sorry, the first bit in the byte, we called it lowest significant bit. And the last bit in the byte, we called it most significant bit. Why we called it lowest significant bit and most significant bit? Because the value is changed. As you see here, 2 power 0, it's give me 1. 2 power 1, it's give me 2. 2 power 2, it's give me 4. So it's base 2 and the number is doubling. The value is changed. More you move to the left, the value is changed. For that, they called it LSP and MSP. All right. If I want to represent 65 in binary system, I will choose the first bit and the bit number 7. Because we have just 2 bits on in this byte. If you see, as you see now on the screen, the first bit it's on and the bit number 7 it's on. So 1 plus 64 is represent 65 in the decimal system or in our normal system numbers. So this byte or this bytes, this byte, it's represent for me 65. But if I want to represent number 3 in binary system, as you see down 1 1 and the rest is zeros. So the first 2 bits it's on and the rest is zeros. Why? Because 1 plus 2 it's give me 3. That's how we represent number 3 in binary system. If I want to represent, for example, number 8, all of them they will be off except bit number 4. And as you see it down, it will be 0001 0000. So That's how you represent number 8 in binary system, because all of them, they will be off, as I said, only or except the bit number 4 from this byte. If I want to represent number 21, all the bits, it will be off, as you see, except bit number 1 and bit number 3 and bit number 5, and the rest, it will be off. For that, it will represent for me 21 in decimal number. 1 plus 4 plus 16 is 21. And the binary system is strong. Why is strong? Because it's only one way to represent data in binary. What does mean? It's mean if I told you represent for me 21 in decimal system, number 21 in decimal system, in different way, you can write 15 plus 5 plus 1 is 21. 21 and half plus half is 21. 20 plus 1 is 21. This in decimal number, in our normal ordinary numbers that we use in our life every day. But in binary system, only one way to represent data in binary. You cannot create 21 unless that you choose and turn on these bits in the byte. So it's strong and can be rely on it because it's only one way to represent data in binary system in computer. So if we ask ourselves a question, what is the biggest number in this byte? The biggest number, if I turn them all on, all of them 111 as you saw it on screen, and I count the numbers down, 1 plus 2 plus 4, 8, 16, 32, 64, 128. If I count them all, it will give me 255. So this is the biggest number in this byte. If I count them all the numbers down, it will give me 255. Okay, if I want to represent 257, I will bring the first byte, I'll put next to it second byte, and I will take the first byte, the first bit from the first byte, and the first bit from the second byte, and it will represent for me 257. And if you recognize here something, that the second byte, it starts from 2 power 8, 2 power 9, 2 power 10, which means it will give us more value. It will double more the numbers and give us more value. And now if we ask ourselves, what is the biggest number in 2 bytes, and all of them on, all these 2 bytes on, all of them 1111, it will give us 65,535. So, which means, if you recognize here something and you focus here a little bit with me, not sleeping ready, that the first byte, it just gives us 255, which means I can store data, but not that huge data. But when I add just another byte, when I add just the second byte, the value is jump till 65,535, which means I can store a lot of data now in just 2 bytes. And that's why the binary system is strong. All right, we represent number in binary, but how to represent letters in computer? How to represent like A, B, C, these letters, how to represent it? Okay, there is something called ASCII table and Unicode table. First, we'll start with ASCII table. ASCII table stands for American Standard Code for Information Interchange, which means, as you see here, number A, it's represented as 65, number B is represented as 66, number Z is represented at 90. Capital letter. But the small letter, number A, small letter, it's 97, it starts from 97, and small letter Z, it's end with 122. Why? Because computers, it's a sensitive case. Computer, it doesn't know this is, it doesn't take them as a 1. When you write capital letter, A capital letter, and you write next to it A small letter, it's different to the computer because it's sensitive case, and you will understand the letter in the next lessons. And when I put for you this table, I don't want you to take picture for it and write it and you try to memorize it, put it in your brain. No, I just want you to understand that there is something called ASCII table that represents the letters of English with the special characters. That's it. Just I want you to understand it. That's it. To have clue about it. All right. So how to represent letters in computer in binary system? As we said, is 65, and 65 also we said is represent A. So it's 65 or A, capital letter A. So how's the computer now is the question. If you focus also with me, not sleeping already, you will ask me a great question now. How you should ask yourself a question. How the computer understand that you're typing now 65 as a number or 65 as a capital letter A? I told the computer doesn't understand. The computer, like, it doesn't distinguish between them. It depends about the context. How? I will give you an example. If I call you right now and I told you, hi, how are you? 65. You told me I'm good, but what do you mean with 65? You will not understand because I don't put 65 in context. But if I told you your internet bill is $65, you told me, thank you, you told me. If I told you your electricity bill is $65, you will understand. Why? Because I take the 65, the number, and I put it in context. Same the computer. When you type a letter sentence, computer understand that you now type a letter sentence. When you type a numbers, computer understand. It depends about the context in your typing, computer understand it. That's we represent letters in computer and numbers. This is an example, like what this mean in binary in our language, for example. What this mean? This is binary system numbers, but what does it mean in our language? It's mean I love you. When you write in the night, I love you to your girlfriend, computer take it, change it to this number and send it to her. All right. And how to represent another languages in computer? We said that ASCII table just for one language, the language is English. But the other languages, Indian, Arabic, Chinese, with their special characters, with their everything, how can be represented? We have something called Unicode table, as we said. Unicode table is an international character encoding standard that assign a code to every character and symbol in every language in the world. All the words, all the words and the letters and the characters of all the languages in the world, with their special characters, with everything, Unicode handle it. So let us have a very fast comparing between ASCII code and Unicode. ASCII table, sorry, and Unicode. ASCII table stands for American Standard Code for Information Interchange, as we said, and Unicode is Universal Coding System. ASCII code is small specific characters, less space, and Unicode large number of character, large space. ASCII code has two standards, 7-bit and 8-bit. 7-bit, it has 128 characters, and 8-bit, it has 256 characters. So it's small, it just has two standards. Unicode, it has three standards, UTF-8, 256 characters, UTF-16, 65,535 characters, UTF-32, 4 billion and something next to it characters. Enough for billion characters, it's a lot. ASCII code or ASCII table, sorry, only one language, Unicode, any combination of languages. So now we have a small homework for you, and I want you to write it down below in the comment. Represent those numbers in binary: 512, 44, 129, 999, 717, and also write your name, first name or last name, whatever you want, or your lover name, or our channel name in a binary system, and put it down below in the comments. I will check it out. This was for the lesson of today. See you next lesson, guys. Ciao.